Free body diagram. A free body diagram shows the chosen body by itself, free from its surroundings. Okay, and we show all the forces or the vectors with their magnitudes as well as directions of all the forces acting on this body. This free body diagram helps us to identify relevant forces in many problems in mechanics. So when we draw the free body diagram, include all the forces acting on this particular body, but not forces that this body exerts on any other body. And whether a force exists, we'll ask the question, what body exerts this force? For example, weight will be a force exerted by the Earth's gravitational pull, by the Earth. And the length of the vector will be important, is proportional to the magnitude of the force. Okay, look at example 3.2.1. You have a block A lying on horizontal surface tied to a string that goes over a smooth or frictionless pulley, and there's a vertical object B hanging from the same string. Okay, we assume pulley is frictionless, so don't have to consider any frictional force over the pulley. Okay, first we draw a rough sketch of the forces that might be present in on A and on B. For A, first thing we expect will be weight, right? And of course there'll be a normal contact force, equal and opposite magnitude, that keeps it at rest. And we also will have two other forces. There's a rope there, or a string, so we expect that there will be tension in this force, in the rope itself, tension. And on any surface in general, unless stated otherwise, we expect there will be a friction. Okay, so we indicate all the possible forces for A. Once that's done, okay, now we can draw the forces on A separately. So for A, we expect a normal contact force from the bottom surface, and we label it normal contact force. There's of course the weight acting from the center of the object. So draw this force slightly to one side of the normal contact force. So you can see that this weight should be acting from the center of the object A. There's a horizontal frictional force to the left, and it acts on the surface of A, horizontal surface that A is lying on. So this will be my frictional force. Label it. Normal contact force is here. And finally, there's a rope, okay, pulling on A, and you draw it at exactly the same position that the rope is touching A, and label this tension. So altogether, you have four forces acting on A. Next, we look at B. B, there's weight, right? That comes to mind. First force, weight, acting vertically down, and it's not in contact with any force. It's only in contact with the rope hanging up there. So this rope must be exerting a tension T. There's only a single rope, so the tension throughout this rope should be the same, T. Okay, so with that, now we can draw the free body diagram for B alone. So weight, B will have a weight from the center of the object, label it weight, and there's a tension. The rope is starting from the top of the object B, so we draw starting from there and label it tension. So we have free body diagrams of A and B separately.